with left and right Riemann sums. Okay, so approximating the area between each of x and the x-axis from this point to this point using right Riemann sums with equal subdivisions. Great, so we are starting from this point and we're ending over here. They said 3 equal subdivisions, so the distance between -2 and 4 is 6, and if we divide that, we get 2, which means it's going to, so the width is going to be the length of 2. So we have another subdivision here, and then another subdivision here. 2, 2, 2. We're talking about right Riemann sum, so we're going to care about the rightmost point of the subdivision. Rightmost point of this subdivision is over here, and the rightmost point of the last subdivision is this. Okay, so let's start. 2 times, okay, the first 4 plus 2 times 6 plus 2 times 4. Technically, this can also be rewritten as 4, but I mean, I choose to write it this way so it can be easier to see. Okay, so anyways, we have 14 times 2, which is 28. So let's see if 28 is correct. Yay! Okay, approximate the area between the x-axis and g of x from -2 to 2 using the right Riemann sum and 4 equal subdivisions. Okay, the distance is 4. 4 divided by 4 is 1, which means the width will be 1 unit long. So we're starting here and we're ending here. We're talking about right Riemann sums, so we're going to care about everything to the right. So we're going to care about this point, this point, this point, and this point. And I should have 4 points because we're having 4 subdivisions. So yeah, -1. So the first g of -1 is 1/2. I'm not going to write the 1 in front because it doesn't really matter whether it's in front or not. And then anything raised to the 0th power is 1 plus 1. Okay, so 2 raised to the first power is 2, and then 2 raised to the second power is 4. Okay, so I'm going to get 7.5. So I'll write 7.5. Correct. Okay, next, approximate the area 0 to 8 using the right Riemann sum. Oh, we're getting all right Riemann sums with 3 unequal subdivisions. Unequal, which means it doesn't matter the distance. So these are the 3 subdivisions we have. This is subdivision 1, this is subdivision 2, this is subdivision 3. And since we're talking about right Riemann sums, right red, we're going to care about everything to the rightmost, we're going to care about the rightmost point. And so for the first subdivision, the rightmost point is this. For the second, it's this. And for the third, it's this. Okay, let's use green to write it out. So the distance between the first subdivision is 3. And then the rightmost point is 5, okay? And then for the second one, it's 1. And then 2, sorry, what am I even writing here at this point? It's 7, yes. So this 1 is the width or the distance between the x's, and the 7 is the rightmost point, the rightmost f of x. 4 and 8, 4, then the rightmost point is this one. So we have 15, 7, and 44, which will give us 66. Let's check. That's correct. Okay. Okay, approximate the area 0, 7. Oh, finally a left Riemann sum with 3 unequal subdivisions. Okay, let's make our subdivisions. This is subdivision 1. This is subdivision 2. And this is subdivision 3. Okay. We're talking about the left Riemann sum, so we're going to care about all the values towards the left. So, which would be this one, this value, and this value for the first, second, and third subdivision. Okay, let's use purple. So the width for the first subdivision is 2, and the leftmost point is 8. And then the width for the second subdivision is 3, and the leftmost point is 6. The width for the last subdivision is 2, and the leftmost point is 3. So we have 16 plus 18 plus 6. Okay, we have 16 plus 18 plus 6. We have 40. Okay, 40